Johnny Storm can heat up to 1,000,000 degrees Fahrenheit. But his base heat, his power would disintegrate your entire circuit in just 10 milliseconds. Since we will never need to use that much power in a low power DC circuit, let's determine the amount of power you will need to safely operate one at. Before we take a deep dive into this hot topic of this video, you should know that subscribers of this channel are trading 2 to 4 years of wasted time in a traditional class setting for hands-on hacks that can be used today. So if you want to be a time traveler with the brain power of a 21st century Tesla, join us. Now that you've chosen to set the level of your understanding of electronics to light speed, let's look at a real-life example of how to use the power formula. Today you decided you want to create a LED power flashlight with a 9-volt battery, 6 resistors, a switch, and 6 2.5-volt blue LEDs. After calculating resistance needed, you can now figure out how much power you will need by using the formula. For this example, where power equals the voltage squared divided by resistance, that voltage is calculated by taking the difference between the battery voltage minus the LED voltage and squaring that difference and then dividing that by the resistor. As you can see in this example, we're going to use 9 volts minus 2.5 volts, and the difference of that by 220 ohms, which will give us 192 milliwatts. With this simple calculation, you now know how to avoid torching your circuit. You know how to calculate the power and how to calculate the wattage size of the resistor to use in your next electronics project. To see more tutorials and project ideas for beginners, click the link in the description box below this video.